Hi students, today we will discuss about file operations. Before going to the actual concept of file operations, at first we will see what is the use of files in C programming. So the first topic is why files are needed. As if now we have been using the functions such as scanf and printf to read and write data. These are console-oriented input-output functions, which are always use the terminals like keyboard and screen as the target place. This works fine as long as the data is small. But in the case of large volume of data, the console-oriented input-output operations will produce two major problems. In that, the first one is, it is very difficult to handle large volume of data through terminals. Second one is, the entire data is lost when either the program is terminated or the computer is turned off. So for solving these two problems, we can use files. So here we will see what are the advantages of using a file in C programming. And that first one is storing in a file will preserve our data even if the program terminates. Second one, if we have a file containing all the data, we can easily access the contents of the file using a few commands in C. Then third one, with the help of file, we can easily move our data from one computer to another computer without any changes. So these are some points. From these points, we can understand that we can use files in C programming. So with the help of file, we can preserve our data. Next is the types of files. There are two kinds of files. They are text files and binary files. The text files will contain ASCII format of data. In text files, the ASCII codes of digits, alphabets, and symbols will be present. In the case of text file, the files will be saved as .txt files. We move to binary file. The binary file will contains a collection of zeros and ones. In the case of binary file, the files will be saved as .bin or .exe files. Next, we will see the basic file operations in C programming. There are four major operations on files. They are opening bar creating a file, closing a file, reading a file, and the last one, writing in a file. So before going to the basic operations of a file, at first we will see how to declare a file. So for declaring a file, we have to follow a particular syntax. That is file *fptr then semicolon. Here file is the data structure. The data structure of a file defined as file in the library of standard input-output function definition. Therefore, all files should be declared as type file before they are used. Then after this file, we'll have *fptr. Here, fptr represents the name of the file pointer. So what is the significance of using this fptr is accessing a file can be done only through this file pointer. Then second one, the file pointer points to the content of the file. So for understanding more about this declaration, consider an example, that is file *fp. Here file represents the data structure and fp represents a file pointer. Fp is the name of the file pointer. Next, we will see how to opening or creating a file. Opening a file is performed using the fopen function. So consider the syntax of fopen function, that is fptr equal to fopen inside the bracket, inside the double quotes, we will put filename.txt, then put a comma, then inside another double quotes, we will put mod, then put at last we will put the semicolon. Here fptr indicates the name of the file pointer. Fopen is the function used for opening the file, then filename.txt. On this place, we will put the name of the file we are decided to open. Then next we'll have mod. This mod indicates for what purpose we are opening this file. There are three modes. They are read mode, write mode, and append mode. In that, read mode indicates that this particular file is open for reading a data from the file. Then write mode indicates that this file is open for writing a particular data into the file. Then the third mode is append mode. Append mode indicates that without losing the existing content, we can add some data into the file. So for understanding more about the syntax, we need some examples. So consider the example number 1, that is fp equal to fopen. Inside the bracket, inside the double quotes, we will put input.txt, then put a comma, then inside another double quotes, we will put r, then at last we will put the semicolon. Here this fp indicates the name of the file pointer. Then fopen is the function used for open this file. Input.txt is the file name. Then r is the mode. So this r indicates that this file is open for reading a particular data from the file. Then another example is fp1 equal to fopen. Then inside the bracket, inside the double quotes, input.txt. Then we'll put a comma. Then inside another double quotes, we will put w. At last, we will put the semicolon. Here, fp1 indicates the name of the file pointer. Then fopen indicates the function used for open this file. Then input.txt is the file name and w is the mode. This mode tells that this file is open for writing a particular data into the file. The next is modes of operation of a file. So for understanding different modes, we can use this table. That is, consider this table. This table contains two columns. First column title is mode and second column title is description of that particular mode. So first mode is R, means open a text file in reading mode. W, opens or create a text file in writing mode. A, opens a text file in append mode. R plus, opens a text file in both reading and writing mode. W plus, opens a text file in both reading and writing mode. A plus, opens a text file in both reading and writing mode. RB, opens a text file in reading mode. WB, opens or create a binary file in writing mode. AB, opens a binary file in append mode. RB plus, opens a binary file in both reading and writing mode. WB plus, opens a binary file in both reading and writing mode. AB plus, opens a binary file in both reading and writing mode. The next is how to close a file. The file, whether it is text or binary, should be closed after reading or writing. Closing a file is performed using the function fclose. So syntax of fclose function is fclose, inside the bracket fptr, then we'll put the semicolon. Here fclose is the function used for closing the file. fptr indicates the name of the file pointer. Then we will put the semicolon. So for explaining more about this syntax, consider the example fclose, inside the bracket fp, then we will put a semicolon. Here fclose is the function used for closing the file. fp indicates the name of the file pointer. Then at last put the semicolon. Next, we will see input and output operations on files. Here we will see different types of functions. used in files for reading and writing data. At first, we will see the getC and putC functions. They are character-oriented functions. So let's move to getC function. It is used to read a character from a file. Then the syntax of getC function is, at first we will put the variable name that is equal to getC. Inside the bracket we will have fptr, then we will put the semicolon. Here on the place of variable name we will put the name of the variable we used. Then after that we will have getC function. Then with the help of this function we can read a character from the file. Then we will have fptr. On the place of fptr, we will put the name of the file pointer. Then for understanding more about the syntax, consider the example that is C equal to getC. Inside the bracket, we will put fp, then we will put the semicolon. Here C is the name of the variable, then getC is the function, then inside the bracket we will have fp. fp is the name of the file pointer we used here. Then we will put a semicolon. When executing this code, actually what happens is, with the help of getC function, a character from the file will be read and that character will be stored inside the variable C. Next we goes to putC function. It is used to write a character to a file. The syntax of putC function is putC. Inside the bracket, at first we will put the variable name, then we put a comma, then we will have fptr, then at last we will put the semicolon. Here putC is the function used to write a character to a file. Then on the place of variable name, we will put the name of the variable we used. Then at last we will have fptr. Here we will put the name of the file pointer. Then consider the example that is putC. Inside the bracket we will have C, fp. Then we will put a semicolon. Here putC is the function and C is the name of the variable and fp is the name of the file pointer. When executing this particular code, actually what happens is, with the help of this putC function, the character present in the variable C will be copied or print to the file. Next we will see how getC and putC functions will work inside a program. Here actually what happens inside this program is, we will write some data into the console, then that data will be print on the file. Then after that the data present on the file will be copied and that is print on the console. So let's move to the program. At first we will write the header file, that is #include stdio.h. This header file will carry all the functions we used in the file. Then after that we will have void main. Then inside void main section, at first we will declare the file, that is file *fp. Here file is the data structure and fp is the name of the file pointer. Then we have to declare a variable, that is char ch. Then after that we have to create and open a particular file. Its name is fog and its corresponding mode is write mode. So the statement will be like this: fp equal to fopen inside the bracket, inside the double quotes, fog.txt, then we'll put a comma, then inside another double quotes we will put the mode, that is w. So after executing this statement, what happens is, a file, its name is fog, that will be created and opened and its corresponding mode is writing mode. That means this file is open for writing some value into the file. So here I am showing a storage location. Here we can see that a file, its name is fog, is created here. Then our next aim is, we have to write some data into this fog file. So for that, at first we will call a printf function. Inside the printf we will write a particular statement, that is enter data. So this statement will be print on the console. When we see this statement, we will write some data in the console. So the data we return in the console is programming in C. Our aim is we have to copy this data into our file. So for that purpose, we will call a while loop. So the condition we return inside the while loop is ch is equal to getChar, that is not equal to end of file. When this condition is satisfied, we move to the body of the loop. So inside the body of the loop, we'll write the putC function. So the putC function will be like this. PutC, inside the bracket we will have ch comma fp. Actually, what happens here is the getChar function will fetch at a time one character, and that character is copied in the variable ch. Then with the help of this putC function, the data or the character present in the variable will be copied in the file. That process will continue until we will put a end of file character. So what happens is, at first we will put p. That p will be fetched by the getChar, and that is stored in the variable ch. Then the character present in the variable ch will be copied to the file with help of putC function. And this process will continue until we put the end of file character. We know that the case of string, the end of file character will happen when we put control Z. Then after executing the statement, the data will print on the console, that is programming in C, that is surely print or surely copied on the file. Then after that, we will close the file. Then again, we will open the file. This time we will open the file for reading the data present on the file. So the statement will be fp fopen, the name of the file. Then we will put a comma. Then inside the double quotes, we will put the mode. Here the mode is read mode, that is R. So again the file is opened. Here the purpose is here the mode is read mode. Then now our aim is we have to copy the data present on the file, and that must be printed on the console. For that operation, again we will call the help of while loop. The condition we return inside the while loop is ch equal to getC fp not equal to end of file. When this condition is satisfied, we move to the body of the loop. Here we will call a printf function. With the printf function, the data present on the variable ch will be printed on the console. Then here with the help of getC, each of the character will be fetched, and that will be printed with the help of printf function. This process will continue until end of file reached. After that, we will close the file with the help of fclose function. Next, we will see getW and putW functions. The getW and putW functions are very similar to getC and putC functions. The getC and putC functions, they are character-oriented functions. But in the case of getW and putW functions, they are integer-oriented functions. So at first we will see getW function. It is used to read an integer from a file. Its corresponding syntax is variable name equal to getW, then inside the bracket fptr, then we'll put the semicolon. For understanding more about the syntax, consider the example, that is C equal to getW. Inside the bracket, we will have fp, then put the semicolon. Here, C is the variable name. Then getW is the function used to read an integer from a file. Then inside the bracket, we will have fp. fp indicates the name of the file pointer. Actually, what happens in this particular code is, with the help of getW function, the integer present in the file will be read, and that integer will be copied in the variable C. Then next we goes to putW function. It is used to write an integer to a file. Its syntax is putC. Inside the bracket, we will have variable name, then put a comma, and after that fptr, then put the semicolon. So for understanding this, we will use an example, that is putW C comma fp, then we will put the semicolon. Here putW is the function used to write an integer to a file. then C is the variable name, then FP is the name of the file pointer. Actually, what happens here is, with the help of this put W function, the integer present in the variable C will be copied into the file. Next, we will see fscanf and fprintf functions. At first, fscanf function, it is used to read a set of data from a file. Its syntax is fscanf, inside the bracket we will have fptr, then put a comma, then inside double quotes control string, then another comma, then list, then we will put a semicolon. Here fscanf is the file function that is used to read a set of data from a file. Then fptr, here we will put the name of the file pointer. Then control string, that will specifies the field format in which the data is to be entered. Then list, here we will put the address locations of the variables. So for understanding more about this syntax, we will consider an example, that is fscanf. Inside the bracket we will have f1, then inside double quotes we will have %d, %s, comma, ampersand quantity, comma, item, then we will put a semicolon. Here fscanf is the function, then f1, this indicates the name of the file pointer. Then inside the double quotes we will have two fields, one will be %d, another one will be %s. Here d indicates an integer data, then %s, this s indicates string of characters. Then this ampersand quantity indicates the address location of the variable quantity. Then this item indicates the address location of the string item. When this code executed, actually what happens is, the file contains an integer data and a string of characters. The integer data is read from the file and that is stored in the variable quantity. Then the string of characters is also read from the file and that will be stored in the string item. The next function is fprintf function, that is used to write a set of data to a file. Its corresponding syntax is fprintf, inside the bracket fptr, comma, then inside double quotes control string, comma, list, then we will close the bracket, then we will put a semicolon. Here fprintf is the function used to write a set of data to a file. fptr will indicate the name of the file pointer. The control string specifies the field format in which the data is to be entered. Then list indicates the name of the variables used here. Then for understanding more about syntax, consider the example, that is fprintf, inside the bracket f2 comma, inside double quotes %d, %s, comma, quantity, item. At last we will put the semicolon. Here fprintf is the function, then f2 is the name of the file pointer, then %d and %s. Here d indicates an integer data, s indicates string of characters, then quantity is the variable name, then item is the name of the string. When executed this particular code, actually what happens here is, the integer data that is present inside the variable quantity, that is written into the file. Then after that we will have a string. That string contains a string of characters that is also written into the file. Next we will see how the fprintf and fscanf functions will work inside a program. Actually what happens inside this program is, a string of characters is directly written into the file, and after that particular data is read from the file and that is printed on the console. So let us go to the program. At first we will write the header file, that is #include stdio.h. this header file will carry all the functions used in the file. Then after that we'll have void main. Then inside the main section, at first we will declare the file, that is file star fp, then put a semicolon. Here this fp indicates the name of the file pointer. Then after that we have to declare the string, that is char buff. Inside a square bracket we will put the size of the string, then we will put a semicolon. Then after that we have to open the file. For that we will write this statement, that is fp equal to fopen. Inside the bracket, inside the double quotes we will put sib.txt, then comma, then inside another set of double quotes we will put w, then we will put the semicolon. Here fp indicates the name of the file pointer, then fopen is the function used for open the file, then sib.txt, this is the file name, then w, this indicates the mode. After executing the statement, what happened here is a file will be created, its name will be sib, and its mode is write mode. So this shows a storage location. Here we can see that the sib file is created. Then after that the fprintf function will executed. So actually what we written inside fprintf is fprintf, inside the square bracket we will put fp, then put a comma, then inside double quotes we will put a set of characters, that is hello world, then we will put the semicolon. Actually what happened here is the hello world will be directly print on the file. Then next, after that operation we have to close the file. So for that we will call the fclose function. The statement will be like this: fclose, inside the bracket we'll put fp, then we'll put a semicolon. Here fp indicates the name of the file pointer. Then after that we will again open the file. So the opening statement will be like this: fp equal to fopen, inside the bracket, inside the double quotes we will put the file name, then we will put a comma, then inside the double quotes we will put the mode. Here the mode is read mode. So this statement is used for open the file zip and its mode is read mode. Then after that what we are going to do is we will read the string of characters present in the file, and that will be print on the console. So for that here we will use a while loop. Inside the while loop we will put a condition, that is fscanf, inside the bracket fp comma double quotes we'll put percentages, then we will put a comma, then after that we will write the string name, that is buff, and that is not equal to end of file. That is a condition we written inside the while loop. So with the help of this fscanf function, the data present in the file will be read, and inside after the while loop condition is satisfied, we will go to a particular body of the while loop. Inside that we will have printf function. So with the help of fscanf, this characters will be read, and with the help of this printf function, that characters will be print on the console. This process will continue until the end of file point reached. Then after this while loop operation, the data will be printed on the console. The data is hello world. The same data is present in the file, that is hello world. That data is printed on the console. Then after that operation, we have to close the file. For that, we will call the fclose function, that is fclose. Inside fp, we will put a semicolon. Here, fp is the name of the file pointer. Next is fwrite function. The fwrite function is used to write records, that means sequence of bytes, to the file. A record may be an array or a structure. So at first we will see the syntax of fwrite function. That is fwrite, inside the bracket we will have ptr, comma, size, comma, n, comma, fptr. Then at last we will put a semicolon. Here ptr is the reference of an array or a structure stored in the memory. Actually, this PTR will give the address of memory location where the array or a structure is stored. Then next we will have size. Size is the total number of bytes to be written into the file. Then next one is n. N is the number of times a record will be write into a file. The last one is the FPTR. FPTR will give the name of the file pointer. So for understanding more about this fwrite function, we will see a program. Actually, what happens inside this program is a particular data we written on the console will be write into a file with the help of fwrite function. So let's move to the program. At first, we will write the header file, that is #include stdio.h. Then we will have void main. Inside the main, at first we will declare a structure, that is struct emp. Then this structure have two variables. First variable is inno. Then the data type of the inno variable is int. The thing we stored inside this variable is employer number. Then we will have a string. Its name is ename. Then its data type is char. The data we stored inside the string is employer's name. Then after that we will have e. Here e is the structure variable. Then we will declare the file, that is file *fp. Here fp is the name of the file pointer. Then we have to open the file. Then for that purpose, we will write the statement, that is fp is equal to fopen. Inside the bracket, inside the double quotes, we'll have emp.txt. Then we'll put a comma. Then inside another double quotes, we will write w. That means here fp is the name of the file pointer. fopen is the function used for open the file. Then emp.txt is the file name. Then W indicates the mode. This W indicates write mode. That means this file is open for writing some value into the file. Then next we will have a printf. Inside the printf, we will have this statement, that is enter employee number. That statement will be written on the console. Then after printing the statement, we will write the employee number. So here the employee number is 10. That 10 will be stored in the inno variable of the structure with the help of the scanf function. Then after that, we will have another printf. The statement inside that printf is enter employee name. So that statement will be printed on the console, that is enter employee name. Then we will write the employee name, that will be Roshni. So here the employee name Roshni will be stored inside the string variable of the structure with the help of the scanf function. So with the help of this two printf and scanf, the data will be stored inside the structure. Then our next aim is the data present in the structure must be write into a file. For that purpose, we will use the fwrite function. So the fwrite function will be like this. Fwrite, inside the bracket, at first we will write &e. We know that in the case of fwrite syntax, at first we will have ptr. Then on the place of this ptr, we will put &e. The &e will give the address of the memory location of the structure. Then after that, here we will have size. So the size will give the total number of bytes to be written into the file. So for finding that, we will call this code, that is size of e. This will give the total number of bytes to be written into the file. Then after that, we'll have n. Then n is the number of times a record will be written into the file. Here the number of times a record will be written to the file is 1. And after that, we will have to write the file pointer. So after that, we will call a printf function for printing store. Next, we will have a fwrite function. The fwrite function is used to read bytes from the file. The fwrite function is very similar to fwrite function. We know that the fwrite function is used to write bytes into the file. Here we will have a fwrite function that is used to read bytes from the file. Then we will see the syntax of a fwrite function. The syntax of fwrite function is very similar to fwrite function. So consider the syntax, that is fread. Inside the bracket we'll have ptr, comma, size, comma, n, comma, fptr. At last we will have a semicolon. Here ptr is the reference of an array or a structure stored in the memory. Then we will have size. Size is the total number of bytes to be read from the file. Then we'll have n. N is the number of times a record will be read from the file. Then at last we will have fptr. fptr, at the place of fptr we will put the name of the file pointer. So for understanding more about this fread function, we will see a program. Actually what happens inside the program is, then this here we will use a structure. That structure is the same structure we used at the fwrite function program. So at the time of fwrite function program, we will write some data, some structured data into the file. So in this program, what happens is that data will be read with the help of a fread function, and that same data will be printed on the console. So let's move to the program. At first, we will write the header file, that is #include stdio.h. Then we will have the void main. Then inside the main section, at first we will declare the structure. So this is the same structure we used at the fwrite function program. So that is struct emp. Then inside the structure we will have two variables. One variable is eno. Eno stands for is the variable that is used for storing employee number. Then next we will have a string. The name of the string is ename. Then the string is used for storing employee name. Then after that we will have this E represents the structure variable. Then we will declare the file, that is file star fp. Here fp is the name of the file pointer. Then we will open the file. So here also we will open the same file we used at the fwrite function program. So the name of that file is emp. So the corresponding code is fp is equal to fopen, inside the bracket, inside double quotes, emp.txt. Then we will put a comma. Then we will put the mode. Here the mode is read mode. So the statements, when the statement executed, what happens is the same emp file will be opened, and the mode of opening this file is read. Then after that, we have with the help of fread function, we will read the data present in the emp file. So the fread function will be like this: fread. Inside the bracket we'll have &e. This &e will give us the address of this structure. Then next we have to put the size of the data we are going to read from this file. For finding that, we'll put this code, that is size of e. So this will give the size of data we are going to read from the file. Then next we will have the number of times the record will be read from this file. On the place we will put 1. Then at last we will put the name of the file pointer. Then we will use a printf function. So with the help of this fread function, we already read the data. Then with the help of these two printf functions, those data read from the file will be printed on the console. So the data will be employee number is 10 and employer name will be Roshni. Next, FEOF function. The FEOF function is also known as end of file function. It is a file handling function in C programming language which is used to find the end of a file. It returns the value 0 when end of the file has not occurred. Otherwise, it returns 1. Next is the syntax of FEOF function, that is FEOF. Inside the bracket, we will put FPTR, then we will put a semicolon. Here, FEOF is the function that is used for finding whether the file reached end of file or not. Then we will have FPTR. On the place of FPTR, we will put the name of the file pointer. So consider the example, that is FEOF. Inside the bracket we'll have FP, then we'll put a semicolon. Here FP is the name of the file pointer.